Welcome to another edition of Chicago Crossing Model Railroad at the Bench. It's me, Eric, here with you on a Saturday. It's finally a little bit cold in Denver. How about that? Today wanted to go back into LED lighting for model railroads and talk about a couple of options that I have come upon that might be interesting for you if you are working on lighting buildings and structures or putting in streetlights and things like that for your model railroad. And before I get into that, just wanted to give a shout out to my friend Thomas out in Virginia. He's been a longtime viewer of the channel. And Thomas sent me a lovely Chicago South Shore GP40 locomotive, he says, as a third-year anniversary gift for the Chicago Crossing Model Railroad channel. Anyway, I should mention that Thomas and his son came out to Denver for a wedding, and while they were out here, they got to join up with me and visit the layout down here in the train room. It was really such a pleasure to have them. So first up, wanted to talk a little bit about constant current drivers. This is a product from a company called kg2v.com. This company was founded and is run by a viewer of my channel named Charlie. Charlie actually turned me on to constant current diodes as a technology for limiting current into LED lit buildings or for any LED. As you know, what you need to do if you're running an LED off of a naked voltage source is to include a resistor in the pathway, because excessive current will burn out an LED. A constant current diode basically serves as a hard limiter for the amount of current that comes through, allowing you to then use a wide range of voltages to actually power numerous LEDs. So in this case, what I've done is I've basically hooked up the PCB here to one of my buildings. This is the Big Bay Lumber building. It's currently undergoing a redo both of the interior and of the interior lighting, but I do have an LED in there, so it can kind of serve as a convenient test subject. All right, so what I've got in here is actually one of these large Woodland Scenics stick-on LEDs. It's actually like a cluster of, I think, 4 different chips in there or something. It's not just a naked single LED. So currently what you can see here is I've got about 6 volts running through. These things usually require a fair bit higher voltage in order to get all of them to run. And so now you can see at around 9 or 10, I've actually got some light coming out of the building. You can kind of see it coming through all the different windows there. What you notice is, in this case, this LED driver basically is limited at 2.3 milliamps. And so something that you may notice here is that you really can turn up voltage and you don't see further brightness on that LED. So it's current limited, and that's literally because of the fact that this thing is keeping current at about 2.3 milliamps. So yeah, pretty cool. If you don't want to use resistors, this is certainly one particular approach that you can take. So the company also produces another much smaller chip, and this is a look at it here. This is basically a 1.7, I think, milliamp driver. It doesn't have screw terminals in it like the other one, but it does have solder pads, so you can actually solder wires into there. Otherwise, it more or less has the same thing. You can see it's got a bridge rectifier. So that allows it to run off of either AC or DC power. It has, as many LED accessories do, a capacitor in order to limit things like flicker. And then it also has the CCD chip right there, so you can kind of just see that. Anyway, interesting little bit of technology. Full disclosure, Charlie sent these to me gratis, simply to be able to play with and have a look at. So as with anything, I offer my review of an item and you decide what you want to do. I never do paid endorsements or anything like that, but certainly it's kind of Charlie to send these over just to have a look at. What you can see on the larger chip is, again, basically the same kind of technology. You have a rectifier, you have a capacitor, and of course you also have the little tiny constant current diode in there as well. So potential use for this type of technology, well, one option is that you can mount it inside of a building, or you can mount it underneath a building and simply have the wires to, say, the clip on the other side coming up. Really up to you. It's another option out there, and probably there are many other uses that I haven't really thought of. This particular product here, given its size, might even be mountable in certain rail cars. N scale, possibly. HO scale or larger, absolutely so, if you wanted to use that in order to run internal lighting. The next item worth talking about here is this light hub right here. As we talked about before, what the Just Plug light hub is basically a JST or Japan Standard terminal using box that has in the interior a series of resistors, a rectifier, as well as individual potentiometers to adjust the brightness of the 4 channels that you see here. It takes a input through JST at 24 volts, and that is sufficient in order to drive a series of LEDs coming out of these outputs here. So what you see here is a product from OONO. OONO, not really sure exactly how to go by that. It's a product of a company, I believe, called czhlabs.com. However, it's something that you can find on Amazon. And there's a few potential advantages to this system. First off, it does basically everything that a Woodland Scenics Just Plug light hub will do. It has individual potentiometers here that can be turned simply using a screwdriver blade, as you see here, in order to dim down or to brighten LEDs on each channel. The other thing it has is it has a jumpered control here that can be used also to accommodate an individual on-off switch for this particular board. The particularly nice thing about this is, rather than using JST terminals, which of course limits you to either having to reconstruct wires into a JST format, all you need to do here is basically take wires and screw them into these screw terminals as you see here. So that offers a little bit more ease of use and a little bit more versatility in terms of what this system can actually accept. A lot of people may have these Woodland Scenics LED setups where you, of course, have the large stick-on LED system here, and it terminates in a JST plug. Well, if you feel like you want to keep that JST plug, then the only thing you need to do is actually just to buy a series of pre-soldered adapters like you see here. This is 20 gauge wire. It's flexible wire, and you can basically trim that to what you want and then run it into that terminal if that's what you want to do. So what that means is you can basically run pretty much any format of wire into this particular terminal. This might be good for things like streetlights or high density lighting for one particular structure. For me, I might actually end up using this for the refinery, which is basically the Ameripan oil facility that'll have a lot of small LEDs all trunking down underneath the layout. So this might actually be used for that rather than using a Just Plug system, which again doesn't quite provide the same level of density. So this is simply a high versatility, high density option that can provide lighting for your layout without necessarily having to use the Woodland Scenics system, and still to have the same advantages as you would otherwise. So anyway, let's crank up the voltage on the power supply. I've got 2 LEDs in here. We can just take a look at how that works. All right, so we'll go ahead, power up the voltage. These things typically don't light until about 9 or 10 volts. Again, I think there's like multiple LED chips in there, so for that reason it takes a little bit of power to actually get them going. So this is 12 volts here. You can see you're basically drawing about 3 milliamps. One thing you notice is, unlike that constant current driver, this is a variable rather than a constant brightness system. Kind of a nice product. We should actually just open this up and take a look inside. Most likely what it contains are chip resistors. So let's do a quick pop open and see what's in there. So when you open this, basically what you do is you take off an end cap that has a little mounting bracket for a wood screw. This actually does come with its own screws there, as you see, but essentially it's like you can mount this on a DIN rail, which is kind of cool, but almost everything that this company sells actually is compatible with a DIN rail mounting. If we take a look at the device itself, on the underside you get a picture of what all is going on here. So as with the light hub system from Woodwind Xenix, you also have, once again, a rectifier. You have what appears to be a diode over here of some sort. This looks to be a capacitor. And then you've got a series of these 680 ohm resistors. And then you have some additional resistors over here that appear to be tied to the potentiometers that you see, which are essentially bound over here into the PCB. So it is a pretty cool system. In many ways, it actually operates very much like the Just Plug system does in terms of the overall principle and overall design. It just happens that you get a little bit more bang for your buck in terms of the number of ports that are available there. So last up, thought it would be worthwhile to talk a little bit about LED light strips and some solutions for those. You know, this is about one of the most cost-effective ways that you can light a building, is using these LED strips. And of course, there's a number of different manufacturers for them. In this case, this is something close to about 16 feet. We used a little bit of it to light the underside of a cabinet in the garage. Now, when you get these strips, one end terminates in a plug for a 12-volt adapter. But of course, if you don't use it all, then what you do is you snip those strips where these copper contacts are. And those basically create individual units of 3 LEDs, as you can see here. The great thing about them is they have a resistor already built in. It's basically a 240 ohm resistor that is working with each of these 3 diodes here. And these run off of 12 volt power. So potentially what you have is 16 feet worth of buildings that you can illuminate with quite bright LEDs that you can basically get in a number of different colors. And indeed, these LEDs can be dimmed down as well if you so choose. So the question is how best to use these, because once you cut these, now what you need to do is, of course, just do some soldering on those pads. But if you would prefer a solderless option, there actually is one. So currently on Amazon, you can actually get these individual blocks. These are basically screw terminal blocks that are specifically designed to be compatible with these LED light strips. And on one side, they have screw terminals that will accept a wire, something like an 18 to 22 gauge wire. And on the other side, what you can see is there's an insertion point where the screws will actually come down onto the individual pads, the copper pads that basically serve as power conductors for that light strip. So what you end up with is basically a component that looks sort of like this. I've already attached this to the wiring, but essentially what you can see is you've got a terminal for your wire, and then you've got a terminal for the strip. So that's a 2-second easy solution for actually taking these individual strips and then mounting them to be powered. So let's take a look at how that is under lighting conditions. Well, answer is, here we're giving it about 9 volts. These things are rated for 12 based on the resistor that's there. And so, of course, you can see you get, what you would anticipate, a dimmable and relatively bright LED system that you can use on a 12-volt power supply. So all told, there's a new set of 3 different solutions that can help make LED lighting relatively painless on your model railroad. All right, we'll leave it at that. Have a great rest of the weekend, and talk to you soon down here in the train room. Take care.